Welcome to my first video. I'm Rodi and I've been working in QA and automation for about 15 years now. Traditional QA as we know it has been dead in the water for already a long time. So where is QA actually heading? Let's take a deeper look at that evolution, or as I like to call it, the Q-volution. In this episode, we'll look at where QA used to make sense and why that changed. We'll explore how development and QA started moving at different speeds, and where cracks began to appear in today's process. From there, we'll shift quality to the left, showing how QA evolves from a reactive role to a proactive one, where quality isn't something you verify at the end, but something built in every change. So let's dive right in. We all know traditional QA is dead, right? That's old news. But in order for us to move forward, we need to understand where QA came from and how it evolved into what it is today. As you might know, back in the Waterfall days, everything was really slow and heavy. It took months to complete. There were 4 big phases: the requirement phase, the design phase, the implementation phase, and the verification phase, all happening one after the other. And by the time it reached the verification phase, QA could finally test the application. But funny enough, some of the old way of working still shows up in how QA operates today. So let's take a look at how Waterfall transitioned into Agile and what actually changed for QA. Spoiler alert, almost nothing. Agile really changed how we work, and most of the changes happened for developers and DevOps. We got faster releases, automated pipelines, and much shorter feedback loops. But QA basically stayed the same, even though test automation was happening right under our nose. We were working together, but in different cycles with no shared feedback loop. QA didn't really evolve like development and DevOps did. We basically stayed in our own lane, still acting as the gatekeeper at the very end of the process. So when a developer writes code, it gets reviewed, merged, and deployed. But QA isn't involved in any of those steps until the code is already live in an acceptance environment. QA and development might work together, but they're definitely not in sync with each other. They're running in completely different cycles, and this is exactly the point what most companies don't talk about. So how does that actually look in practice? Let's take a look at the symptoms. So imagine we have multiple teams, and these teams are deploying simultaneously on the same day to acceptance. That means we are testing different versions of the code on a shared testing environment. And when something breaks, development has to dig through a pile of commits just to figure out which deployment actually caused the problem. Most of the time, test automation starts in that shared environment. A test that might have worked earlier might already fail after the next deployment, because currently quality assurance is done so late in the process. That means feedback also arrives too late, because the code is already merged. So if anyone then starts testing the ticket which the developer worked on, the developer has already changed context. So if a bug is then found during that stage, it's a very expensive one to solve. Oftentimes it's like 100 times more expensive than finding it in development. Development is shipping and promoting code really fast, but QA is still preparing tests for features that are already deployed on acceptance. Both are busy, but just not on the same thing, meaning you have disconnected teams that are out of sync, working in different cycles within the same iteration. When we're talking about limited visibility, that often means that the test results are buried deep inside the pipelines. Stakeholders who actually need that information, like product owners or team leads, have to really dig through job logs or pipeline stages just to find what failed. And because that takes time, most of the time they simply just don't. Let's see what happens when QA actually evolves. As stated earlier in this video, a lot of companies believe that they are fully working agile, but they're still testing too late in the process, meaning that they are still reactively testing their application. At the right side, QA actually becomes more proactive. In this case, we are just using a shift left methodology. This is definitely not a new concept, guys. It already exists for a while. In order to shift testing to the left in a successful way, quality assurance should be done on the feature branch where the code from the developer can be merged together with the created tests. So instead of waiting for code to be merged and deployed to an acceptance environment, testing is done much earlier in the process. efficiently shifting testing to the left. This then actually creates a shared feedback cycle, so quality runs in parallel with development built in every change. And this is where the real transformation begins. A lot of what I'm about to show you is inspired by the modern day DevOps practices. Now, if you're familiar with the YouTube channel Tech World with Nana, you'll probably recognize some of these tools, like Terraform, Docker, and Ansible. But this time we are going to use them from a QA point of view to build dynamic test environments. Imagine we're in a team and a developer and a QA are working on the same feature. When the developer creates a feature branch and opens a merge request, in the meanwhile, the QA starts writing the test for the same branch. Not later, not after deployment, but right now and there on the same ticket. Both the feature code and the test should be part of the same merge request. That merge request now includes two things. One, the code from the developer, and two, the test code from the QA. That merge request then triggers the pipeline, and it doesn't really matter if it's Jenkins, GitLab CI, or GitHub Actions, doesn't matter, as long as it runs in a CI/CD tool. When we talk about an ephemeral environment, we talk about an environment that is there only temporarily. In this case, we need a temporary environment in the merge request to be able to run our application stack. If we do that, we can then run our test against that stack. We would need to create an environment on a cloud hosting provider such as AWS, but that can also be another cloud provider. So if we then want to create that environment, we can just use Terraform to create it on AWS. This is called infrastructure as code and can be done during a pipeline run. Once that environment has been created, we also want to be able to deploy our application stack into it. But in order to do that, we need a tool that can configure the environment. We can do that with a tool called Ansible. That tool installs all dependencies, like Docker, command line tools, and so on. After we've configured the environment on runtime in the pipeline with Ansible, we can then start the application stack with Docker Compose. The same concept can also be achieved differently, for example with Kubernetes. But for now, Kubernetes is a little bit more advanced. Once the environment is ready, the test can actually run. Which test run depends on what changed. So if we make a change in folder A, the pipeline knows it should trigger the test from folder A, even though the test might live somewhere else. In this stage in the pipeline, we are only running what is relevant at this moment. The key here is that all these tests run inside the same temporary environment we just created. We isolate our tests and tie it only to the merge request we are testing. There are no other stakeholders at this point in time testing on that temporary environment, so there's no cross-contamination whatsoever. As mentioned before, in this stage we're testing different test levels, so we can test integration, component, or even end-to-end tests. It really depends on the code of the feature branch. If the test passes, everything from that run gets stored automatically. We store the Docker image that we tested, and we want to store obviously the test report with the test results. For test reporting in this example I used Allure reporting, but you can use any tool you like. It doesn't really matter if we're testing a monolith or a microservice, the data from that version on the test should always be stored in that report. Because we want to create full transparency and visibility for our key stakeholders, eventually we don't want to store these artifacts in the pipeline. In the next stage we are actually going to store these artifacts based on versions. That way it's easy to trace the results to a specific version, commit, or even a build. We already touched upon this a bit, but we want to be able to show test results and product quality at any moment. That's why we want to store all these build artifacts versioned in a tool called Nexus. It's basically an artifact storage where every build, every test result, and every report is saved and traceable. So let's say we want to find the test results for a specific release. For example, version 1.4.2 for the user manager service. In Nexus, we can easily just search that version, open the report, and then immediately see what was tested back then and which environment it used, because we've stored all that data in the report. So after we've successfully stored the artifacts from the previous step, we want to actually deploy them on an acceptance environment that resembles production. This is then where we can run a full regression test across different test levels to validate how the system actually behaves in a production-like setup. To deploy the versions that we've tested, we can use tools like Kubernetes or EKS on AWS. It really depends, of course, on what your company uses. And yeah, I get it. Not every QA engineer is going to spin up a Kubernetes cluster themselves. But it's important to understand how this fits in the bigger picture, because this is where quality and delivery actually meet. In most teams and companies, performance testing is treated as an afterthought because it's more important to build features than checking performance metrics. Once the images are deployed on acceptance, it's the perfect time to test the performance. We can do those things with tools like K6 or Gatling to make sure we really don't deploy something to production that actually decreases the speed of the system. Acceptance, in my opinion, should always reflect production as closely as possible because it's the last hurdle before an actual release. Once the test run, we can then actually measure the metrics with observability tools like Grafana and Prometheus. They can actually help us understand how the system behaves under load. Once we see that everything works as expected, the temporary environment is torn down and the feedback loop can be closed. Usually we can do something like that by sending a Slack or a Teams notification to inform the stakeholders that everything is working as expected. You see, this is QA evolving with DevOps. We're still the gatekeeper, but just a much smarter one. I've explained the Q-volution now from the technical side, but that shift also brings a new kind of engineer. An engineer who doesn't just test or automate, but actually builds quality into every pipeline in a much smarter way than before. They are the bridge between QA and DevOps because they speak the same language: infrastructure, testing, and even delivery. They are not just collecting metrics, they actually make results and insights visible for every stakeholder, because quality in the end is everyone's responsibility. They drive continuous feedback in every stage of the process along the way. This, in my opinion, is the new breed of engineer. So, to summarize, traditional QA is as dead as a floppy disk. Learning DevOps skills isn't optional anymore. It's essential if you want to evolve. The gap between QA and DevOps is closing really fast. And those who adapt will define the future of quality. Because this shift, this Q-volution, is only just getting started. So, ladies and gentlemen, that's the Q-volution in a nutshell. QA evolving into something much faster, smarter, and finally in sync with DevOps. But we're just getting started. Next up, we're going hands-on. I'll show you exactly how to bring QA into the merge, how to make those ideas from today real inside your own pipeline. This is where we build the Q-volution. But for now, I'd love to hear your thoughts on this video. Do you see QA moving into the same direction? Let me know in the comments, and see you next time.